In this part of sequences and series, which can also be referred to as progressions, we would look at two kinds of series. One which would be called as a finite series, which simply means that there is a finite number of terms in that particular sequence, and hence what that means is there is a definite last term in that particular sequence. On the other hand, if you have an infinite series, then what that would mean is that it goes on and on indefinitely with no particular last term, which means that the number of terms is infinite. Let's look at the first type of progression, which would be called as arithmetic progression or AP. Now, characteristic of an arithmetic progression is that the difference between any two consecutive terms remains the same. So, which means that if we have these terms given as terms in arithmetic progression, then it would mean that b minus a is equal to c minus b, which is equal to d minus c, which means difference between any two consecutive terms always remains the same. Now let's look at a few formulae for arithmetic progression. If we denote our first term as a, and if we denote the common difference as d, then we have a formula for the nth term in an arithmetic progression, which is given as a plus n minus 1 into d. So if we want to find the nth term, any value for an nth term, given the first term and the common difference, then we would straight away use this formula a plus n minus 1 into d. This gives us the value of the nth term. On the other hand, we have a formula which is Sn, which would mean sum of the first n terms of the arithmetic progression, and this formula is n upon 2 multiplied by 2a plus n minus 1 into d. So this formula would give us the value for sum of the first n terms in the arithmetic progression. Now it is possible to write 2a as a plus a, and if we take 1a with this n minus 1 into d, then it is nothing but the formula for the nth term, and hence Sn can also be written as n upon 2 multiplied by the first term a plus the nth term, which is also the last term. So there are two formulae that we can remember for Sn. It is n upon 2 into 2a plus n minus 1 into d, which is nothing but n upon 2 into first term plus last term. So these are the various formulae for arithmetic progression. Let's look at another kind of a progression, which is called geometric progression, which can also be referred to as GP. Now the characteristic in a geometric progression is that the ratio of any two consecutive terms remains the same. So if we say a, b, c and d are in geometric progression, then it would mean b upon a is equal to c upon b, which is equal to d upon c, which means the ratio between any two consecutive terms remains the same. If we denote the first term as a, and if we denote this common ratio as r, then we have a formula for nth term in a geometric progression, which is given as a into r raised to n minus 1. So if the value of a and r are given to us, then we can find out the value of any nth term in that geometric progression. Sn would give us the formula for sum of the first n terms in a geometric progression, and this formula would be a multiplied by r raised to n minus 1 upon r minus 1. Now we would use this formula if the common ratio r is greater than 1, but if the common ratio r is less than 1, then we would use the formula a into 1 minus r raised to n upon 1 minus r. So these are the formulae for the nth term and the sum of the first n terms in a geometric progression. Arithmetic progression and geometric progression that we've seen till now, we spoke about finite number of terms since we had formulae for the nth term. Let's now look at a case of an infinitely diminishing series. So what are we talking about? The number of terms is infinite, it goes on indefinitely, and it is a diminishing series, which means the values go on reducing. So if we talk about a geometric progression with infinite terms such that r is less than 1, which means that it is diminishing, and if we now look at the formula that we had just seen in a geometric progression for Sn where r is less than 1, we had said the formula is a into 1 minus r raised to n upon 1 minus r. Now in this case, if we are looking at infinite number of terms, and hence if we want to find the sum of all these infinite terms, if n becomes infinite, then r raised to n would almost become 0, and hence the formula would reduce to a upon 1 minus r. So if we have an infinitely diminishing geometric progression, r obviously is less than 1, and if we want to find the sum of all these terms, then the formula is as simple as a upon 1 minus r.